We're going to talk about different best management practices during this section, kind of from the design standpoint, and then kind of talk about different types of practices that are going to be at your site, what you're shooting for with those practices, and thank you. Kind of where you're going to go with these things. Think about the size of your site, the plans for your disturbed area. You know, we've had several questions today about, well, you know, our overall site is going to be 40 acres or 60 acres of disturbed soil, but we're only going to do it, you know, 10 acres at a time or 20 acres at a time or whatever it is that you've decided on doing. You can kind of see that that's the direction that this is going, is smaller site disturbance at any given time. Getting away from the old one-time mobilization type stuff that you saw, well, even 10 years ago, where, you know, I've got an example of a site that was approximately 80 acres, and they built a sonic in one corner of it. After the lawsuits and us getting involved and other things, they finally, after about 3 or 4 years, got some vegetation established. Oh, and I also claim, now it's not true, but I claim that I'm the one who got piccolos back in the sonics through that deal. Because it was with the parent corporation that we had the enforcement. And I claim that I strong-armed them, you know, using strong-arm tactics to get piccolos back in the sonics. I love piccolos, and so I demanded that they have piccolos. But, you know, you think about having a single mobilization to clear off a site that you're only planning on using a small portion of anyway. You say, well, you know, we need the whole thing cleared eventually. Well, that's fine, but, you know, to keep the sediment on the site, it's better to leave it undisturbed until you need to do that. And then think about drainage. You know, I talked a little bit about it being a geographical law or a natural law that being in rolling hill country, you're going to have topography that lends itself to runoff that's going to yield a lot of sediment just by virtue of the fact that you've got a lot of slopes. In some parts of the state, you have tremendous slopes. But those types of things, you know, the sheet flow runoff quickly turns into concentrated flow when you've got very much slope at all. So think about the site. The drainage controls are going to need to, they're going to need to be designed for those types of things. And then scheduling. Our average heavy rainfall times are in the spring and the fall. Everybody knows that. But, you know, with the drought that we've been going through, you kind of take it for granted that you're going to be able to get all the work you need to get done without any rainfall causing you problems. But, you know, from time to time, you'll hit an extended period of rainfall that gives you fits. And usually that's going to be in the spring and the fall. You can see that average winter is by far the best time to get something done in the state. The summer's pretty good too, but we can expect rainfall in the spring and in the fall, generally speaking, when we're not in this kind of severe drought cycle that we've been in. But one time in December, I was doing an inspection of a site. The guy hadn't fixed his controls like I'd told him to do, and I said, you know, it's going to rain. And he said, I know it's in the forecast, but, you know, we're in the dry time of the year, and maybe they'll get it wrong. Don't bank on it. You know, bank on that it's going to go wrong. Bank on the Murphy's Law type deal that what can go wrong will go wrong. I've already talked about disturbance is necessary. Now, perimeter controls, before we go very much further with perimeter controls, how many of you have seen a design where the site or where the plan calls for a silt fence all the way around the outside? You know, from time to time you're going to see those, probably most of the time. Are they necessary? Is it necessary to have that control running all the way around the outside? And it may be that there could be wording in there in the narrative part that says that it's going to be where applicable. It doesn't mean for you to, but it's on the map that it shows that. Go out there and look at your site. Your site will tell you where the water is going to flow, and especially during a rain event. During a rain event, the water is going to tell you where it's going to want to flow. The topography of the site is going to tell you where that water is going to come off at. So establish perimeter controls first, realizing that after you disturb, you're going to be wanting to do construction activities. We recognize that fact. Go ahead and establish those controls first. And then think about mature vegetation. Is there anywhere in the perimeter that you can have mature vegetation that you don't need to disturb right up to the edge of your property line? If you can have mature vegetation either before or after a silt fence, it's probably going to do you way more good than the silt fence is. So try to maintain that mature vegetation as much as possible. Now, when you're talking about erosion or sediment, you say, well, what's the difference? I've seen an erosion control design, I've seen a sediment control design or whatever. The cycle of sediment is where those terms come from. First of all, you got to have detachment. The soil particles have to come apart. And for the most part, they tend to stay glued together. But you think about the size of a raindrop compared to the size of the dirt particles. And as the rain falls on the site, it's like little bombs hitting that and blasting those dirt particles apart. And then they start to lift it up. That's the entrainment part of the cycle. They lift up those dirt particles as the energy is maintained by the water as it begins to run off. And then it begins to transport those particles away from where they were originally. And then eventually they're going to deposit it. They'll either deposit it in your controls that you have at your site, or they'll deposit it in a stream nearby, or they'll deposit it in the lake that the stream leads to. So, that's where the deposit, or it may be in the Gulf of Mexico. So if you've ever seen any aerial shots of the Gulf of Mexico, the massive amount of deposition that's been going on down there, that's where it's going to go eventually. And maybe it'll help those folks out in their delta. This is a graphical illustration of what we're talking about there, and it has to do with the diameter and the flow velocity, diameter of the sediment. You say, well, what are we talking about here? We're talking about small clay, the very, very fine small particles and stuff like that. Dr. Vogel has done all this stuff with the buffers and everything. That's what this has to do with. And so the settling velocity has to do with the diameter of the sediment versus the energy there that's in the water, the flow velocity itself. And so there are certain types of physics laws that this has to bow to, and in order for you to get it to settle out, you've got to provide low enough velocities, approaching zero for clay. You may even forget about it for clay. You may have to have some sort of coagulant, not a coagulant. What's the word I'm looking for? I said the same thing. Thank you. Flocculants. To pull those clay particles together to get them big enough to settle out. So that's what you're looking at. And it's best if you can avoid that situation up front. If you can minimize the amount of clays that are exposed to rainwater, you'll minimize the turbidity of the water. You heard that term, turbidity. I shudder when I hear that term because turbidity is not a measure of the sediment transport in the water. Turbidity is a measure of the cloudiness of the water. And it's a measure of how much clay may be in the water. There are even some other things that can cause turbidity besides clay. But we're kind of stuck with turbidity, even though, if you'll pardon the expression, it's kind of a voodoo way of going about trying to get sediment transport on water. But it's really not a good measure of the sediment. Sediment generally is moving in the bottom part of the water column because it's heavy. It's the sand and stuff like that, and that's where your tonnage is. But most of the time when we get calls complaining about a site that's they're silting up the creek, or they're sending a bunch of sediment and silt down the creek, most of the time it's clay heavy water. It's got a lot of clay in it, and it may have some small sandbars and stuff, but it's not necessarily carrying a lot of tonnage, but they can see it really well. So remember that as you're disturbing your site. When you go out there and strip off the topsoil, that's what you're exposing, is the real fine stuff that's going to run off and cause you to have some headaches there. Particle transport has to do, again, with energy. Now, these were some folks who had taken a DCS vehicle out to a site and warned them not to go down there by that slope because there was a lot of clay on that slope. And even I didn't want to set foot on that slope because it was steep. So if you think of me as the particle or the DCS vehicle as the particle, you know, you get enough energy and you get the steepness factor up there enough and away they go. And they're going down into that sediment basin where they finally came to rest, just like the sediment particles do. And we didn't stay around. I'm assuming they probably got it out of there eventually. But Brian, were you with me on that deal? No, that was somebody else. That was at Ada, by the way. And they had gone down there to do an inspection. They wanted to go down there and see the sediment basin. I said, don't drive down there, but they did. So, you know, don't get on a steep slope if you're a very big particle, because you'll just slide right down in there. I said it, didn't I? Not necessarily reflect the views of management. Whenever you're developing your site, BMPs, you're looking at management of runoff, trying to maneuver it into position so that you can take advantage of the natural topography of your site to get the sedimentation under control. You're going to use detention, you know, holding it back just long enough to kind of get it to settle out a little bit. Retention, holding it back for a long time, you know, and retaining the stuff on the site. Really, it's best if you don't let the water run off at all, and that's what retention is. Attenuation is a fancy word for saying using a berm or something to kind of guide the water around your site, to try to attenuate the flow, not letting it run off really fast, which is kind of counterintuitive for us engineers because we think, well, we got to get rid of that water out of here fast. And as far as it being on a roadway, yeah, you don't want it on a roadway because you're going to cause accidents and maybe get somebody hurt. But as far as it running off of a site, you don't want it to run off fast. It's going to carry a lot more sediment with it if it does. And then infiltrating that water on your site, using a combination of that stuff really is going to get you the most bang for your buck. And then we referred to it earlier, velocity dissipation devices. You know, I talked a little bit earlier also about playing ball in the first quarter. Start thinking about these controls as being various points in the ball game that you're starting to play ball. And erosion control, not disturbing it until you have to, using things to try to keep the rain from getting the soil picked up in the first place. That's playing ball in the first quarter, you know, and you're going to win the game if you do that. Don't wait until the last quarter, which is where the water's running off the side as fast as it can go now, and it's carrying a bunch of stuff, and it's got a lot of particles in train in the bottom of the column, and it's turbid, and you can't really see it. You know, that's what's going to happen to you. You're going to be limited to playing ball in that last quarter if you wait that long, and it'll come up and bite you. So we've talked about that already, but this is kind of pictorially what we're talking about. So beat it before it gets started. Don't disturb if you don't have to. You're just asking for trouble. Lower left there is a site where the soil was very sandy. It wanted to move. It was ready to move. And once he got it uncovered, it moved. And it went down and deposited in the creek. And then it migrated down that creek and went off the site. Can't remember the name of that lake up there. It's in the Choctaw-Hara area. And the one on the right there is the 80 acres that they cleared for the Sonic in the corner. Different types of erosion controls that you can use besides leaving it undisturbed until you need to. There are erosion control blankets that are available where you just unroll the stuff out there, and it's got straw in a net mesh fabric. Turf reinforcement mats, which looks like silt fence basically, but it's big rolls or mats of it, and you can tie that in, and it can take some amazing, boy, the word just escaped me, Dr. Vogel, shear stresses. Yeah, thank you. It can really withstand a lot of that. You can lay that out in the bottoms of channels and things. And then also surface roughening, which you might not think of that as being in erosion control, but if it's tracked properly there on the right side and the tracks are actually running horizontal, perpendicular to the flow path, it'll slow the water down enough so that it'll have time to kind of pause as it's trying to run down that hill. Don't let the dozer operator say, yeah, I'm tracking this, and they're tracking it where that their tracks are running in line so that they're minimizing the erosion that's going to occur, because that won't minimize it. That just encourages it and gets it off there faster. So, excuse me. Vegetative mulches are very effective when they're applied properly. You want one where basically you almost can't see the ground. 80% coverage is what you're looking for there, and 80% coverage is almost no ground visible. If you have the ability, if you've got the equipment, and you can kind of think of it as using it in a different way, wood chips work real well. If you've got a chipper or something like that available, and you're having to clear a lot of trees, run them through the chipper, blow them out on that disturbed soil you've got there, and it does a pretty good job. You can use a tackifier there, that last bullet in the middle, or the last bullet, the hydraulic mulches, where they spray that material on the surface and kind of glues everything together. Those work pretty good. They will break down fairly quickly depending on how close to natural they are. The guar gums and stuff will break down probably within a couple of weeks in the summer, maybe even within a week, kind of depends. But then if you've got it modified in any form or fashion, like a hydroxyethyl cellulose or something like that, those things don't break down as fast. So, or xanthan gum, which would probably be fairly expensive, but it will last forever. Compost blankets, riprap, hydroseeding, hydromulching, all these things are different types of erosion controls that are available to you. They have some dust control products out on the market as well that are used by the military in the desert to establish airports temporary for takeoff and stuff like that. And it's amazing some of the stuff that they've got available for that kind of dust control. The best one is not disturbing it until you need to. That stuff, it doesn't have to run off. Now the thing about this picture is this is coming off of about a 20-acre site, 15, 20-acre site. They've got a lot of clays disturbed there. You can see how turbid the water is. Probably not a lot of tonnage of sediment, but very turbid water. This was in an area where people were very aware of how things looked aesthetically, so you can start kind of guessing what neighborhood this is in. But you know, as far as what they were talking about, did they have a reason to gripe? You know, if you think about it, the background is minimal. Look at how clear that water is coming out of there. I know it's kind of hard to see maybe with this lighting, but don't disturb it until you have to. Basically, there's so little background that occurs because of the way the grass is and the topsoils that we have. It's almost clear water. There is a little bit of background that's going to occur, but not much. So don't disturb it until you have to. Runoff controls are going to reduce the entrainment and transport capacity of the water by reducing the amount of energy in the water running off of your site. So it'll kind of slow down gully type erosion, rill type erosion there in the lower right corner. Grassline channels, you know, the old SCS type stuff, Soil Conservation Service designs on berms and things like that for farms. That same stuff applies. I was talking to a developer in Edmond one time, and I was saying, you know, you need to have some like terraces out here where it kind of guide the water, because he's right on top of the hill. It's going to be a beautiful subdivision and everything. And he said, you mean like what was out here when I got started? I said, yeah. Yeah, see, he had smoothed all that stuff out. And that's fine, but if he just would have known. A lot of it is ignorance. And I'm not saying that in a bad way or trying to bash the guy, but he just didn't know. And so you can help yourself out a lot if you're going in to develop a site that's an old farm or something like that. It may have a bunch of terraces on it already. Then you can just leave them there until you're ready to take them out. So things like rock check dams down in the lower middle there, permanent or temporary diversions of the water, things to slow that water down and knock the sediment out. You can see there in the upper right, that's what happened there in that grassline channel. The water hit there and it slowed down enough that it dropped out all the heavy stuff. Probably there was some red water flowed out of there, but it wasn't carrying a whole lot of sediment. I thought I had some pics there. Lower right corner, that's the Mississippi Delta. A lot of sedimentation occurring in the Mississippi Delta. Lower left corner is the north end of Lake Texoma where I fish. And that's been happening for a lot of years. In the mid-'80s, that was when we had all those floods and everything, carried a huge amount of sediment down there. And there was 20 foot of water there when I was a kid. And now it's about 20 foot of ground. So it's amazing what getting the water still and quiet will do. And basically that was the design of that. You can see the red ribbon there, the Washouts River going in the north end. There's a lot of sediment been dropped in there, just like there's a lot of sediment been dropped in the Gulf. You provide deposition there by setting up some sort of a barrier to the water flow leaving your site. If you do that before it leaves your site, then you're not contributing to those types of things. You can use sediment basins, sediment traps. Traps basically are just small holes, and they can be traps for people like me. Do we have a picture of Robert falling in one? I think we do. Providing some sort of a barrier to the water flow leaving the site. Now this one is one of the kind where you've got a bottom outlet. So it's really not designed to retain any water. This is a detention structure only. But if you can see how far back it settled out the sediment. This is of the same detention structure. And I can't remember how long it is. I think it's something to the tune of about 100 yards long. And it settled out a whole lot of sediment there just by minimizing the amount of water that could leave that area. As far as the permit requirements are concerned, if you have 10 acres of disturbed soil or more draining to one discharge point, you have to provide a sediment basin. You can either do it without a professional engineer's help at 3,600 cubic feet per acre drain. But remember that a deep hole isn't the equivalent of one that's big with a large surface area. It's not big, it's shallow with a large surface area. Shallower with a large surface area is much better than a deep hole that's smaller surface area because you're trying to give it some retention time. You're trying to slow the water down, give it some time in there to drop those particles out. If you have a PE do a design for you, then the basin he designed should hold a 2-year, 24-hour storm event using those depth duration frequency charts by the USGS. Remember that these have to be maintained. If they reach 50% capacity, they're no longer keeping as much sediment as they're sending out. So, once they reach that 50% capacity, they're sending it on through. Now, they may go ahead and fill on up, but they've sent out way more than they kept from 50% on to full. And it won't be totally settled. So I should be able to tell. I shouldn't step off in one. I've seen it happen. You laugh. No, you don't. But the guy went into his hip. And I told him, I said, you're not about to step off in that sediment, are you? But he stepped off in it anyway. This is a site behind, you can tell what that building is, I'm going to say it. And it's past the, it's several years later, so it's okay. This is at a Walmart site. Walmart has gotten very intent about providing these types of structures, reducing the amount of sediment and stuff. We got a guy here that did a lot of these designs for Walmart during his tenure at an engineering firm, and they got serious about it. And so you can see they've got inlet structures there, that rock in the kind of the middle of the picture. The outlet structure is designed a certain way, and They really pay a lot of attention at these sites now. Again, retention time is the key. A 36-foot deep hole, 10 by 10, is not equal to a 60 by 60, 1 foot deep. It's just not. You get a lot better retention time in that large, shallow depression. So also, you know, you can make it wide, and if the entrance is straight across from the exit, you're not going to get a lot of bang for your buck. So think about retention time when you're doing your design. Maybe put a partition in there that makes that water flow way around before it gets to go out. A curtain or something like that. There was a question earlier about outlet structures on these types of sediment basins. A floating outlet will do a great thing for you. Having something where it's pulling water off the surface rather than off the bottom is going to do a lot for you in knocking out sediment. It'll even knock out some clays doing that. Not a huge amount of them, but some of them. This is one of those Walmart structures. Like I say, they got interested in retaining it on site. Now, I have heard it said that I've got a sediment basin. I don't need to worry about all that other stuff. You know, and after we get down to this point, you know, we've been talking about all these other things, playing ball in the first quarter and all that good stuff. But think about the way that the physics is going to work in a sediment basin. And I'm just going to read this. Even at 90% trapping efficiency for bare soil, due to particle size distribution, the sediment discharge from a basin will be significantly greater than for vegetated soils, just due to the fact that vegetation greatly decreases the amount of sediment entering the basin in the first place. If you've got erosion controls and you're playing ball in the first quarter and then you've got something back there in the back side, that sediment basin is going to do a lot more for you when you're not overwhelming it with sediment. When you're not sending so much sediment down there that some of it's going through just by virtue of the fact, think about a blitz. How does a blitz work? Well, you bring in more guys. You swarm in there and you smash the quarterback, right? Because you bring in more guys in there that can be handled. It's the same way with a sediment basin. Don't blitz your sediment basin. Okay? We talked about velocity dissipation. This may look a little bit overkill there, but remember we talked about a rule of thumb for silt fences is about 1/3 of an acre. So, you know, once you get beyond that, again, it's kind of blitzing the silt fence. You're sending more to it than really it can handle. But if you keep it at about 1/3 of an acre that it's trying to handle, it'll do a number for you. It'll really do a good job. There are several different types of things out there. You've seen the pictures of straw wattles that Michelle had earlier, and there are filter berms. I've seen continuous berm here in the state at one site. That's where they put rock in the middle of a silt fence and roll it up there and tack it together. And that stuff really holds in place. It may wash out under it, but it's not going to wash away, at least if it's not in a channel. But the triangle silt dike is another good product that's out there available. And then vegetated buffers. And we're going to talk about buffers later on today and how important that is. You'll see straw wattles installed. Remember that you got to trench those in properly and stake them down so that they'll work right for you. They do a great job when they're installed properly. Drop inlet controls, curb inlet controls. There are a lot of different innovative techniques that I've seen used by people out there. Think about your site. Think about traffic. Bags of rocks may or may not perform for you if you're starting to get some traffic in the area. Those bags of rocks are kind of like car magnets. People tend to drive toward whatever they're looking at, and so they're driving along and they see your rock bags and they drive right over there and run over them. And I don't know why, but that's just kind of the way it works. It's a physics type of a deal and also psychology, and I don't understand people sometimes. If you do any stream diversion on your site, check with the Corps of Engineers before you get involved with that. There may be 401, 404 certifications. that have to be obtained before you can do that kind of work. You know, as far as tree establishment is concerned, sometimes you say, well, you know, we're not interested in tree establishment. That's more of a long-term type of a deal, but a riparian zone will keep a creek in position, whereas if you tear it out, you're asking for trouble. Like I say, there's a number of different types of inlet protection available. Try some stuff. Do what works for you. You can reduce the amount of other types of pollutants that are leaving your site. You know, Michelle had some pictures of some leaking drums and things like that. Be aware of secondary containment type requirements that you may have in SPCC. And your concrete washout needs to be something that people are aware of. It's not a place to wash the truck out completely. That's for back at their site, their concrete batch facility. It's for washing off the tools and chutes, okay? Just kind of rinsing things off. We understand they need to do that so that it doesn't set up on them on the way back. But it's the washing out the truck and stuff is what they take care of back at the site. They'll produce way more water than a site can handle if they try to wash out their truck at the site. There are, I recognize that guy. Oh. There are a number of different commercially available concrete washout facilities, but a simple pit dug to hold that material until you have time to clean it out, and it may need to be cleaned out more often than not during certain periods, like when you're pouring curb and when you're pouring foundations or whatever it is that may be going on. But at other times, you know, it may not be used hardly at all. But be aware that it does need to be signed properly, and the guys need to know where it is so that they can go use it. Now, as far as lot controls are concerned, once you get down to the size of a single lot, you go, wow, you know, it's kind of getting intense. But the thing about it is there may be a number of these lots still dotted throughout any given development. And depending on the weather and stuff, they may really produce a lot of mud out into the street. At one point, I was talking to a guy about it. He said, well, we don't have deliveries during the wet time of the year. And then, lo and behold, here comes a delivery truck. Rolls up there, and so we're just standing there watching. You might remember that. And he got to backing up there, and he really cobbed it, rolled up onto there, and just spinning mud all over the place. And I just kind of looked at the guy and raised my eyebrows, and he goes, he gets on the phone, he says, if you got delivering something down there, tell him to get off of there. Well, you know, count on it happening. You know, it's the Murphy's Law deal. Whatever can go wrong will. Now, granted, those two lower deals may seem like overkill, but they've got very little troubles from those sites. Very little problems. You know, that the site there on the lower left, it shows you right where that water's leaving that site. Maybe they could put just a little slim band of silt fence right there and knock that problem out. That lower right site, they didn't have anything running off of that site. Yeah, it might have been a little bit overkill, but they didn't have any troubles and they didn't have any neighbors complaining. Some curbside sod goes a long ways towards keeping sediment on the site. Street sweeping may be called for. You may need to go talk to the operator of the dump truck who backed up there and dumped stuff right on your silt fence. So, you know, count on those guys not necessarily knowing what that stuff's for. Non-structural best management practices include training, telling people what this stuff's out there for. They may or may not be aware of what they're doing whenever they're destroying your controls. But making them aware of it is something that can help you out a lot. Like I said before, scheduling is a non-structural best management practice. Also, keep things cleaned up around your site. Keeping a neat site is important. When I roll up to do an inspection at a site, if it's real trashy and everything, my first impression is not so great. I'm expecting sloppy. I'm expecting sloppy record keeping, and I'm expecting just general sloppiness because it looks bad. it may not be that great, even if it looks good. But I'll tell you what, if your site looks neat as a pin when I roll up there, I'm not as likely to start digging. But I'm a lot more likely to dig and take up a lot more of your time if your site's sloppy when I roll up there. Think about it from that standpoint. Again, we've got a lot of resources out there. These things will be available to you in the presentations. Here's some phone numbers. If you want to call my boss and complain about me, there it's in Compliance and Enforcement, Wayne T. Craney, 8139. And the rest of us are on there in case you ever need to get a hold of us. We do compliance assistance or technical assistance. If you want us to come take a look at something on a time available basis, we'll come out to your site and take a look and make recommendations or whatever. As a matter of fact, we like to do technical assistance when we have the time to do it. If you've got permit questions, don't call me. Call Amber. Her phone number's there, right there. That's her direct line. And Matt Johnson. I'm not going to leave him out. And if you want to complain about them, their boss is Matt Pace. So I shouldn't have said that. Oh, well. Anybody got any questions?
We're talking about sediment basins during construction. Have you looked into proprietary type stormwater quality devices to capture the suspended solids?
Like tankage type stuff that you can purchase,
right.
Like a self-contained unit that you bring out to your site. Those things are available. I have not seen one in the state of Oklahoma. They may be more in use in areas where there's a zero discharge type deal, like a no tolerance deal for like trout fisheries. Maybe West Coast, maybe North Carolina, stuff like that. I know that there are things like that out there. We don't have a zero discharge on sediment deal here, so I wouldn't necessarily expect to see one. I don't know comparatively, compared to building one, I don't know about cost comparisons either. Sorry about that, but I think that you could probably build one cheaper than you could purchase one. Anybody else?